My name is Muhammad Ali, and my team and I will be presenting our project on the GDELT dataset and the data reality gap in world events. What we're going to be doing is an analysis of this dataset in retrospect to major world events such as Me Too movement and climate change. Our focus is going to be on crime-related data made available, and we intend to perform an assessment on the effectiveness of this dataset in predicting development metrics such as the Global Peace Index. Hopefully, it serves as an analysis on the gap between data and real-time events. Why we're doing this is because crime of different types is an indicator of social, economic, and political status of nations, and the power of real-time data provided by GDEL is revolutionary. However, we are concerned that its basis on news reports could be biased and lead to contributions to the existing gap between data and reality. How we're going to be doing this is through multiple steps, such as exploratory data analysis to identify trends and crime categories and tonalities. We're going to study the Me Too movement through the data set and compare it to the real-time world events, perform analysis on impact climate change has had over crime rates in different regions of the world, and finally try to perform predictive modeling on how to predict the Global Peace Index through the GDELT dataset and whether or not it is a reliable dataset to use that prediction.
So the GDELT organization, or the Global Database of Events, Language, and Tone, encompasses the largest database of human activity ever recorded. 83 million of events stretching from 1979 to today and updated every 15 minutes. They do this by scanning media outlets across the entire world, translating from over 100 different languages in order to extract events recorded through media, and then codify them and save it to their database. This codification occurs through Cameo codes. That's the conflict and mediation event observations. The left here includes just a sample of those codes. There's over 300 different types that end up getting attached to each particular event. So let's look in detail about how this actually happens. Take this statement: the United States criticized Russia yesterday for deploying its troops in Crimea, in which a recent clash with its soldiers left 10 civilians dead. So that short statement is actually talking about three different events. One where a nation state criticizes another where a nation state invades another state, and then lastly, troops ended up injuring civilians. So this short statement ends up including quite a bit of information, as well as who is involved. So we have actor one, the United States, who criticized actor two, and there's a number of different attributes that get built along into each of those actors. They can be nation states, they can be civilians, police force, insurgencies, as well as we have a geographic location. And lastly, we also have a sentiment. And so for each event, the average sentiment of what's being discussed gets recorded.
All right, now let's do some EDA. Okay, so the conflicts in the GDELT dataset are divided into four main categories that are assault, coercion, fight, and use of unconventional mass violence. You can see that assault and coercion make up about 70% of the data, while 20% is made up by fights, and the remaining is by unconventional use of mass violence. Taking a look at assault, we can see some of the assault, some of the crimes that come under assault on the right-hand side and the distribution in the data set. And we can see assault by continent. We can see that North America and Asia have the highest rate of assault in the world. It accounts for about 2/3 of all the crime in the world. Now, the majority of the remaining cases of assault are from Europe, Africa, Australia, and South America. One interesting observation here is that Australia, although being less densely populated country, has a higher rate of assault than all the nations combined in South America. Now, the same trend is observed across all the other categories of conflict. We can also take a look at top 5 countries by assault. Here we see that the US has an extremely high count of assault. This is followed by the United Kingdom, India, China, and Russia. Taking a look at coercion, we see all the crimes that come under coercion on the right-hand side and the distribution. Taking a look at coercion by continent, we see much of the same. We see North America and Asia have the highest rate of coercion in the world, followed by Europe, Africa, Australia, and South America. Again, we see the same trend like we have seen before in the case of assault. We see that the United States has, again, an extremely high count of coercion, followed by UK, India, China, and Russia. In the case of you can see the description of all the crimes that come under the category of fights on the left-hand side and the distribution. We can take a look and see, again, observe the same thing that North America and Asia have the highest fights amongst all the other continents, make up about 2/3 of all the fights in the world, followed by Europe, Africa, Australia, and South America. Coming by top countries, again, we observe the United States has an extremely high number of fights, followed by the UK, India, China, and Russia. Coming to unconventional mass violence, there are three main crimes that come under mass violence. These are mass killings, ethnic cleansing, and mass expulsions. We see much of the same here. North America and Asia have the highest rates of mass violence, followed by Europe, Africa, Australia, and South America. We also see that United States again has the highest rates of mass violence compared to the UK, India, China, and Russia. Now, just summarizing all of the data that we've just taken a look at it across all the different categories, we can see North America has the highest. An interesting observation is that Australia has higher crime across all categories than all the nations in South America combined.
So here we have some ways that this database has been studied over time. In particular, a number of groups have predicted events of social unrest as well as violence in different areas around the world. It's been applied to financial markets, but particularly I want to bring up this concerns about the GDELT database, because this research group worked with the organizers of the database, and we're very concerned about how protective that the organizers were for the mechanics behind its construction. Because from a scientific standpoint, we should be able to reproduce how events end up being recorded. And it turns out that the organizers are the only ones who can see how that's done. We have some concerns as well, particularly about a reality to data gap. And so ideally, the reality is perfectly captured in the database. That's never how it actually happens, but that's the goal. There's some challenges here. First off, with the media, different countries can have very different journalistic environments, and in some areas they are not able to feel safe to reflect their own reality. But in particular, the GDELT database has at times changed how they record events, and we can see that in the database quite clearly. So if we look more specifically, this chart here is comparing the number of events per country, and we can see a clear bias to the United States of America. I think this is both a factor of the United States journalistic environment that is very robust, but it also is probably a bias of the GLT organization in order to better integrate with the United States media organizations. If we look instead at the number of events that recorded over time, we can see that this database reports a strong climb through the late teens and then collapses as we approach 2022. And so we know that the number of events happening in the world from 2004 to 2019 didn't increase by 500%. So this clearly shows that that the way that these events are being picked up has changed. And so what we can do is to try to capture this bias. And by the way, we also saw this pattern play out in every way that we bisected this data. So it's clear that this is something that biases all the way down. So what we can do is capture this bias and then try to remove it. So if we convert the total events to instead proportion of events in order to something that we can compare to smaller subsections, We can then fit a polynomial line. So that blue here is still the count of events or the proportion of events, and then orange is this polynomial fit. And if we then take the observed events and subtract the polynomial fit, we then flatten this out. And so lastly, the only thing that we're adding is as the volume increased, the variability did as well. So if we rescale it, we now have a more consistent count of events over time. And so if we apply this pipeline to a smaller subsection of the data, let's say homicides in El Salvador, if we were to see a drastic increase over the fitted line, we then know that that drastic increase is reality, and which then reverts back to the fitted line. So applying this to there, we would then be able to compare the year 2019 to 2009 so that we could actually see where things are actually changing or dropping. So from here, the next challenge is with some tonal shifts. This is the average tone shift for all events over time. And there's 3 models that GDELT ended up using. And we can see that for a while it's centered at 4, it's centered at 2, and then later it's centered at -4. This is a much easier transformation. We can either add or subtract those averages, push everything back to 0. So then if we wanted to compare 2019 to 2009, we can do that. So with all these flaws that are part of this database, what can we do, in order to still study this? I'm going to pass this off to Lisa now. She has the first example of a case study that we could put into this database.
I'm going to be telling the story of the Me Too movement through the GDELT dataset. Due to the size of this dataset, I found the best way to tell a story was to focus in on a single event code and follow that over the years and across different countries. Let's take a closer look at the single event code 1821, which is the code for sexual assault. But can we even tell a story with this massive data? The answer is yes. Let's begin by focusing on where the Me Too movement first began. For those not familiar with the movement, the Me Too movement is a social movement that's fighting against sexual assault and sexual harassment. The time was 2006, the place New York City, and our fearless leader, Tarana Burke. I put together a timeline of events beginning in 2006 when Tarana Burke coined the phrase Me Too in New York, signifying the beginning of the movement. The movement took off in 2017 following the Harvey Weinstein scandal and the hashtag #MeToo going viral on Twitter. In 2017, the Women of Hollywood launched the Time's Up campaign, and hundreds of thousands of women participated in the 2nd annual Women's March. As you can see by this plot of the GDELT data for instances of sexual assault, things really began to take off in 2006 and peaking in correlation with those major events such as the hashtag and the Harvey Weinstein scandal around 2016 and 2018. Let's zoom out and look at this from a global spread. Top 10 countries in terms of sexual assault instances in the GDELT dataset were the United States, India, the UK, South Africa, Australia, Pakistan, Nigeria, France, Sweden, and Bangladesh. For this presentation, I'm going to be focusing on the top 3. Here are the top 3, the US, UK, and India all plotted together. As you can see, they all took off around 2006 and had peaks around 2013 to 2019. Following our timeline events with the UK in 2018, inspired by the Time's Up movement in the US, a group of UK women in the film industry launched Time's Up UK. And you can see that this is around when it was peaking in the GDELT dataset for sexual assault instances. In India in 2013, the Sexual Harassment of Women in the Workplace Act was passed, and the movement for Me Too was set to take off in 2018 in India following the statement of an actress regarding harassment she faced while filming. These 2 peaks are in correlation with the GDELT dataset and how many times the sexual assault code was referenced and seen in media. Now let's flip the switch and look at the other side of the story. A lack of data can also help add to the narrative. Some of the most populated countries in the world don't even make a top 10 appearance for some events for sexual assault in the GDELT dataset. Why could that be? Are women not being assaulted? Is sexual assault not an issue in these countries? I think there's a bigger issue going on. I decided to focus on China and Russia, 2 countries that are top 10 in terms of population, but didn't even make the top 10 in the GDELT dataset when looking at sexual assault events that were reported. So China is in yellow, Russia is in orange, and as you can see, compared to the top three from before, US, UK, and India, there's barely even a dent. Sexual assault is not being talked about. Doing a simple Google search, I quickly found the answer. Headlines such as China's Me Too victims face abuse and payback for going public. Women are being silenced. Accusations scrubbed from the internet. Discussion heavily censored. Same thing happened when I searched Me Too in Russia. I did hashtag Me Too skip Russia. These are the things we're seeing. Why Russia's Me Too movement has struggled to take off. Putin suggests Me Too is media conspiracy. Next steps we want to look at for the final report are to look at the tone variable. Due to the switch of metrics from GDELT 1.0 to 2.0, it kind of messed with the data. So we're going to try to perform a transformation to remove macro trend data from micro data. And then the last thing we wanted to look into is why around 2019, the number of events talking about sexual assault really took a sharp decrease. Is this because of COVID and the media is focused on reporting COVID rather than sexual assault issues, or are there further problems with the GDELT data set?
The second way we will analyze this database is determining whether crime is affected by climate change. Research has shown that temperature has a strong positive effect on criminal behavior. Within the past few decades, we are seeing drastic climate changes. Certain regions are experiencing more extreme weather due to global warming. The countries that have been affected the most by climate change within the past 20 years are Puerto Rico, Myanmar, and Haiti. Using the global surface temperature data, we will create a yearly and monthly analysis to see if the total events within the GDELT dataset correlate with temperature changes. We will also look at each country's respective mean temperature over time to identify whether crime increases or decreases. Looking at the annual graph, we can definitely see a positive relationship between global surface temperature and crime rate for each country, especially from 2008 to 2014. As the mean global surface temperature is rising from 2008 to 2010, crime rates in the three countries are also rising. Crime rates do taper off or stay the same as surface temperature decreases from 2010 to 2011. Surface temperature is on the rise after 2011 and countries experience a trend of increasing crime. The monthly graph from 2010 to 2015 provides a better look at how crime increases or decreases with respect to surface temperature, specifically the time period from 2012 to 2015. As surface temperature fluctuates in either the positive or negative direction, so does each country's crime rate. Some countries do experience a more drastic change, which is caused by other factors that lead to crime. Let's look at each country's crime rate with respect to their temperature data. Puerto Rico's crime rate does not seem to correlate with mean temperature until after 2008. This could be an issue with bias in the GDELT dataset that was mentioned earlier. After 2008, Puerto Rico's crime rate does fluctuate with respect to mean temperature. Myanmar sees a similar trend. After 2008, the crime rate changes in the same direction as the mean temperature. With Haiti, it is hard to see a correlation between its mean temperature and crime rate. This could be due to the multitude of extreme weather events they experience, causing severe damage to the country. We see large spikes of crime in 2004 and 2010, both of which were years Haiti experienced multiple hurricanes and earthquakes.
So the final part of our project is predicting Global Peace Index using GDELT dataset. Now, the Global Peace Index is a measure that ranks countries based on their peacefulness, and it's produced by the Institute for Economics and Peace around the world. It is based on 23 indicators, majority of which are conflict related, and this is why we chose this approach, because the GDELT dataset that we are focusing on also has to do with crime data. The question would be, will we be able to save international institutions and government the cost of preparing data for GPI by substituting it with the already existing and provided GDELT dataset? To perform this predictive modeling, we went through different steps, first of which is the data preparation, that I'm not going to go into too much depth in, but it involved pairing up the matching GPI indicators to GDELT variables after data cleaning and transformation. We perform training on a rolling basis that predicts 1 to 6 months ahead of time. Upon training, 1 month is dropped from the beginning and 1 is added to the end. In our data set, the last month of provided data was March of 2021, and therefore we predict up to 6 months after that. Now, given that we have n GPI values, we have n 1 month ahead predictions, n-1 2-month predictions, up until n-k being 6. So that's because we can only predict up to 6 months ahead. High parameter selection in dataset involves tenfold cross-validation and splitting the test into training and testing sets. Now, we chose to move with two models, a more basic one, which is random forest and XGBoost, and compare the results of their outcomes. We did perform this for a select number of countries, most of which are centered in the Middle East, given that processing time for these models is immensely long. So in the case of Lebanon, we used XGBoost, right, which is extreme gradient boosting. It is high performing, however difficult to interpret, and this is why we use SHAP values in order to understand the importance of variables, which after the model training and predicting, as we can see, in Lebanon, the highest value in terms of variable importance was unconventional violence. We have arrests, detains, or charges, and sexual assault being top 3. Other than that, there's torture, assassinations, and fights with artillery and tanks. And this is because there are a lot of free arms in the country that are uncontrolled by the government. In terms of model evaluation, we used RMSE and Pearson correlation factor. Before going into those, this is what our prediction looks like. So as we can see, we did perform 12 predictions and over the upcoming 1 to 6 months. And this is what we got in terms of results. Now, as we can see in most of these plots, the month right after our last data point in terms of GPI, which is the red line, is always very close to the actual trend that exists. However, the further we move away from that, the further away the predictions are from the trend of reality. So in terms of XGBoost on the Lebanon data set, we have the root mean squared error and the Pearson correlation coefficient. And as we can see, there is a certain trend when it comes to those. The minimum RMSE was 0.866, and the Pearson correlation coefficient was 0.68. The Pearson correlation coefficient in this case is very good and shows good correlation. However, the root mean squared error does not. In the case of Turkey, we performed random forest and XGBoost in order to compare the results. As we see, as I said previously, the further we get away from the 1 month prediction point, the further away the values get from the actual trend. And we can see that also through the RMSE and Pearson correlation coefficient values, which are both high, good for Pearson, but not good for RMSE. Finally, to compare it, we performed XGBoost, which kind of almost showed the same trend. However, we do have consistency in the Pearson correlation coefficient, but not enough in RMSE. And this goes to show that although this model is good in terms of prediction, it has only proved successful when it predicts 1 month ahead of time.
In conclusion, we analyzed the GDELT dataset in 3 ways: the Me Too movement, climate change, and predicting the Global Peace Index. For the Me Too movement, we were able to map spikes in sexual assault cases to causing major events within the movement to occur. Shortly after these events, the total sexual assault cases dropped. Also, we were able to determine which major countries were trying to suppress the movement by looking at total sexual assault cases for individual countries. By pairing temperature data with GDELT dataset, we were able to identify a positive relationship between temperature and crime rate. As mentioned, other factors could be included in order to establish a stronger relationship. Finally, we created multiple models to try and predict the Global Peace Index for future months. XGBoost proved to be the best model, but the results using the GDELT dataset did not provide definitive results. There were some limitations to using the GDELT dataset. All the data is collected from articles, so different media outlets will view the same event differently. Also, we are not able to verify the data used within GDELT. Due to strict licensing, the creators do not release the articles that the data was created from, or their algorithms are used to identify features such as tone. For future research, we would like to remove bias from the dataset. Looking at the overall dataset, there was a 500% increase in total events from 2009 to 2018. After that, we then see a decrease in events of 500% in a matter of a couple of years. This made it very difficult to identify trends over long periods of time. In order to solve this issue, we created a line which represents macro trends and removed these trends from the original data. This will help in smoothing the large fluctuations in events reported. Also, we would like to expand the monthly temperature data to further regions, as these results were more viable than looking at each year as a single data point. We would also like to include other factors such as unemployment rate to help explain further variability in crime rate.